So electric cell is a device in which a constant potential difference is maintained between its terminals, either by chemical reaction or by mechanical action. So one end of the cell is at higher potential, other end of the cell is at lower potential. And current flows from higher potential to lower potential. Okay, current always flows from higher potential to lower potential. This current is conventional current. And if you're talking about positive charge, yes, we consider flow of positive charge. So positive charge will also flow from higher potential to lower potential. Plus Q charge will flow from higher potential to lower potential. Yes? A cell has two terminals. Terminal which is at higher potential is called positive terminal, and the other which is at lower potential is called negative terminal. The ability of an electric cell to drive charges in a circuit is called EMF of a cell. Ability of an electric cell to drive charges. See, outside the cell, current flows from higher to positive to negative, but inside, charges flow from positive to negative outside, right? But inside, charges have to flow from negative to positive. Then EMF comes into play. Okay, let's take an example here. That suppose we have a water tank, okay, on a roof. It is placed on a roof. So अगर water tank है, we easily get water through that water tank, na? If we want to move this water to a tank which is placed at lower place on the ground, we can say, or anywhere lower level, then it is easy to move water from here to here. What if I want to move water from the tank which is placed at this place to the tank which is placed at a higher place? Then what should we do? Water can easily flow from here, but to move water from this tank to that tank, to a higher tank, we need to add a motor. An electric motor is required. The function which electric motor does here, the same function is done by this EMF. The resistance offered by the electrolyte and electrodes of a cell is called internal resistance of the cell. This is another definition. Internal resistance of the cell. See, resistance of the cell internally, मतलब cell की resistance जो उसकी उससे belong करती है, something which belongs to cell. Internal resistance, है ना? जो उसकी खुद की resistance है cell. अब cell की resistance क्यों होती है? Because in a cell we have electrodes, we have electrolyte, ions also move, है ना? So they offer resistance. And that resistance is called internal resistance of the cell, and we denote internal resistance by small r. There are two resistances that we take in the circuit. One is the load resistance, the capital R, okay? And another resistance is the internal resistance, which is within the cell, which is of the cell. Okay. So this is a cell. You can see here we have two electrodes and they are connected through a wire. And so we have this electrode and electrolyte. This arrow represents flow of charge or flow of current, we can say. Flow of positive charge or flow of current. Okay. But अब ये क्या हो रहा है? This charge has to flow through the cells. This charge has to flow through the cells, but there are, electrolytes and chemicals present in the cells which offer resistance to the charge. Okay. And here comes the function of internal resistance. Internal resistance of an ideal cell must be 0 because an ideal cell offers no resistance at all. Okay. It should not offer any resistance. Okay. It is 0. So cells offer internal resistance to the charge. And here comes the function of electromotive force. Okay. Suppose we have 1 coulomb charge and it is moving through this wire and reaches the other end of the battery. Now it has to go through the cells, all the cells which are connected in series. It has to go through all these cells. Okay. So what is electromotive force? It is the work done by the charge. See, positive to negative में cell can easily flow because charge flows from higher potential to lower potential. है ना? But if a charge has to flow from a lower potential to a higher potential, then work has to be done. Okay, and this work done by the charge per unit charge is the EMF, electromotive force. So the EMF of a cell is called 1 volt if 1 joule of work is performed by the cell to drive 1 coulomb of charge once round the closed circuit. ठीक है, ये क्या है? 1 वोल्ट EMF कब होगा? जब 1 जूल वर्क डन होगा 1 कूलम चार्ज को मूव करवाने के लिए, पूरा कंप्लीट क्लोज सर्किट में मूव करवाने के लिए. ठीक है, डिपेंड करता है जैसे जैसे सेल को आप यूज करते जाते हो आफ्टर सम टाइम. जैसे इनिशियली तो इंटरनल रेजिस्टेंस जो है वो नियरली 0 होती है, बट धीरे धीरे जब हम सेल को यूज करना शुरू करते हैं तो उसकी इंटरनल रेजिस्टेंस इंक्रीज होती जाती है. ठीक है, so SI unit of EMF electromotive force is volt. Its dimension is that of electric potential only, mL2T minus 3 I minus 1. Terminal potential difference. See, this is the potential difference that we consider every time when we had done the numerical problems in the previous chapters. We have discussed, we have considered this potential difference only, V. So we have this cell and these two are the poles of the cell. One is positive, other is negative. Okay. And potential difference between the two poles of a cell in a closed circuit, that is when current is drawn from the cell, is called terminal potential difference. ठीक है, जब क्लोज सर्किट हो गया और उसमें से करंट फ्लो कर रहा है सर्किट, तो जो उसका एंड्स का जो डिफरेंस होगा पोटेंशियल का, उसको हम पोटेंशियल डिफरेंस. नाउ यू नो द डिफरेंस बिटवीन ईएमएफ एंड पोटेंशियल डिफरेंस. ईएमएफ क्या है? वर्क डन बाय द चार्ज टू मूव फ्रॉम नेगेटिव टू पॉजिटिव terminal, and potential difference is the difference in potential when the circuit is closed and current is flowing. Okay, SI unit is volt. Dimensions same है जो EMF की है, mL2T minus 3 I minus 1. Relation between the EMF of a cell and the potential difference between its terminals. So what is the relation between E and V? This is what we are going to do. So let's draw a circuit. So in this circuit we have, you can see a battery of 2 cells and a resistor is connected here, and we have one resistor here. This resistor belongs to the cell. This is the internal resistance of the cell. Sometimes we draw a resistance with the cell. A resistor we draw with the cell. Okay, because हम उसके अंदर कैसे दिखाएं कि उसके अंदर इंटरनल रेजिस्टेंस है उसकी, तो वो उसको हम साथ में ही उसको ड्रॉ कर देते हैं. उसका पर्पस ये होता है कि ये उसकी इंटरनल रेजिस्टेंस है और ये सेल है. ठीक है, so this is one thing. This block is one thing. So E is the EMF and R is the internal resistance. तो ये एक सेल का जो है, ये हमने एक सेल को अलग से we can draw like this. If you want to show the internal resistance or if we are considering internal resistance, then we can draw like this. Okay, and R is the load resistance. R is the resistance which is connected through the wire. है ना, उसके पोल से हमने वायर लिया and there we have connected one more resistor box, resistance box, and that is capital R. So this is EMF, and energy given to the circuit by EMF is. Energy given to the circuit by EMF is, electromotive force is Q into E. See, हमने confuse नहीं होना. This E is potential, another kind of potential है ना. Electromotive force है, work done है ना ये by the charge. Work done per unit charge है. This EMF is work done per unit charge, and if we multiply this work done per unit charge by charge, then we get work done which is equivalent to energy. No? Are you getting what I'm saying? EMF is W by Q, and we are multiplying this by Q. Then we get W, and W is equivalent to energy. So this energy can be written as Q into E, where E is the EMF of the cell. Okay. And R is the, small r is the internal resistance of the cell. So energy spent in sending the charge through the internal resistance. होगा ना? अगर उसकी internal resistance 0 है, जितना भी आपको जो EMF से जो एनर्जी मिल रहा है, जितना भी चार्ज को मिलेगा वो सब से वो पास हो जाएगा उसमें। लेकिन अगर उसका इंटरनल रेजिस्टेंस कुछ है, तब उस केस में क्या होगा? कुछ एनर्जी जो है वो यूज्ड अप होगी, स्पेंड होगी, है ना, उस इंटरनल रेजिस्टेंस के अगेंस्ट वर्क डन करने के लिए, उस इंटरनल रेजिस्टेंस को ओवरकम करने के लिए, राइट? तो वो जो आपकी एनर्जी है, वो यू कैन राइट दैट एनर्जी एज Q into small v. So this is small v. V is the potential, है ना, generated, and Q is the charge which is flowing in the inside the circuit or inside the cell or in the circuit. Similarly, we have external resistance. We have external resistance here, and energy spent in sending the charge through the external resistance R can be written as, if V, capital V, this time we have capital V. Capital V is the potential difference. Okay, and R is the resistance. Q is the charge which is flowing. And then energy spent in sending the charge through the external resistance can be written as Q into capital V. Q is the charge and capital V is the potential difference. Terminal potential difference or potential difference we say, right? तो अभी इस स्लाइड में क्या क्लैरिटी हुई आपको? समझ आ गया? एनी डाउट? तो वन इज EMF, है ना, एनर्जी जो EMF से कनेक्टेड है, दैट्स QE, और जो एनर्जी यूज्ड अप होगी, है ना, वो है Q into small v, और जो एनर्जी आपकी स्पेंड होगी वहां पे इन सेंडिंग द चार्ज थ्रू द एक्सटर्नल रेजिस्टेंस से जब चार्ज आएगा जाएगा, अगेन चार्ज हैज टू डू सम वर्क हैज बीन डन बाय द चार्ज, मैंने जब जाएगा वहां से, है ना, तो वो Q into कैपिटल V होगी। तो टोटल एनर्जी जो हमने दिया था वो क्या था? बताओ। So according to the law of conservation of energy, we can equate energy given, energy transferred or energy spent. Okay, so QE is equal to, we can write QV plus Q into small v. Can we write like this? So this QE is EMF वाला एनर्जी, and Q कैपिटल V क्या है? एक्सटर्नल रेजिस्टेंस में जो एनर्जी स्पेंड हो रही है, मतलब जो हमने एनर्जी दी, वो एनर्जी दो जगह यूटिलाइज हुई है, एक तो इंटरनल रेजिस्टेंस के अगेंस्ट और एक एक्सटर्नल रेजिस्टेंस। जो इंटरनल रेजिस्टेंस के अगेंस्ट है वो Q into small v है, और जो एक्सटर्नल रेजिस्टेंस के अगेंस्ट है वो Q into कैपिटल V। ठीक है, तो नाउ we can write this as V plus V, capital V plus small v. Okay, so therefore E is equal to capital V plus small v. So we can write like this. Now what is this small v? इंटरनल रेजिस्टेंस का क्या क्रॉस जो है। अच्छा एक बात बताओ, जब करंट I फ्लो कर रहा है, चार्ज फ्लो कर रहा है Q, करंट I फ्लो कर रहा है, तो कैन वी अप्लाई ओम्स लॉ हियर? Yes, we can apply Ohm's law here. V is equal to IR. So when we consider this small v, then we take small r, and for capital V, we take capital R. Okay, so we can write this as, so V is I into small r. Okay, now we have just rearranged it. We have moved this to the other side, transpose it, and so we'll get this E minus IR. This is one relation. So capital V is equal to E minus IR. Okay, we use this relation in numerical problems. Any doubt? Sneha, any doubt, bete?
Oh, ma'am.
Continue करें. So thus the terminal potential difference of a cell is always less than the EMF of the cell. We can see we are subtracting something from the EMF of the cell, only then we are getting this terminal potential. है ना? We are getting terminal potential difference by subtracting a quantity IR small r from EMF of the cell. So terminal potential difference is always less than or equal to E. When terminal potential difference is equal to E? When is terminal potential difference equal to E? When there is no internal resistance. If small r is 0, then V equals E. V is equal to E. But if we have internal resistance, in that case, V is less than E. Okay, write this please. Light off कर लो, eyes पे strain बढ़ेगा, अंदर आओ. So this is the equation that we had considered, right? Because QE is equal to QV plus QV, right? So we've cancelled Q from both the sides, so we'll get this. Now this V is IR, yes, and small v is I smaller. So we can write this as, by substituting these values in the above equation, we can write E is equal to I capital R plus I smaller. Now we can move this I outside and we can place this capital R plus small r in the bracket. Okay. So by placing them in the bracket, we get another relation. This is the same relation. We are just writing in different forms. The same thing we are writing in different forms. Okay. I is equal to E upon, this is the current which is flowing in the circuit. General form of, this is the general form of Ohm's law. Because here we are considering internal resistance also, we have simply added this internal resistance to the resistance because they are in series. Okay. So current in the circuit and is equal to EMF, total EMF in the circuit divided by external resistance plus internal resistance. Okay, this is how we write this. Now we have questions based on this. The SI unit of terminal potential difference is volt. Very good. Second question, the dimensional formula for terminal potential difference is. Good. Topic is charging and discharging of electric cell. Open circuit and short circuit, we'll be discussing this. Charging of electric cell means we are charging a cell, and discharging, we are using the cell and it is getting discharged. And open circuit is which is not closed, is open. And short circuit, short कैसे होता है बताओ, बोलते हैं ना short हो गया when we connect the positive and negative directly. जब दो वायर्स कनेक्ट होते हैं तो शॉर्ट हो जाता है ना. शॉर्ट कैसे होता है शॉर्ट, अगर आपके प्लग में दोनों वायर्स कैसे भी ज्वाइन हो जाए गलती से तो स्पार्क प्रोड्यूस होता है ना, शॉर्ट होता है. So discharging of a cell, please write the heading discharging of a cell. When current is drawn from a cell, current inside the cell is from cathode to anode and current outside the cell is from anode to cathode. In this case, EMF is more than the terminal voltage. Here you can see discharging of a cell is taking place. Okay, current is moving from positive to negative. है ना, करंट पॉजिटिव से निकल रहा है और नेगेटिव में एंटर कर रहा है. दिस इज डिस्चार्जिंग ऑफ अ सेल. So in this case, we write terminal potential difference V as equal to E minus IR. Clear? I is the current, R is the internal resistance of the cell, E is the EMF, V is the terminal potential difference. So V is E minus IR. During discharging, V is E minus IR. And charging of a cell is when current is sent into a cell, it is said to be in charging condition. Current inside the cell is carried from anode to cathode. And in this case, potential difference across its terminals is greater than EMF of the cell. अब यहाँ पे क्या हो रहा है? Current पॉजिटिव में एंटर कर रहे चार्ज और नेगेटिव से लीव कर रहे, है ना? पॉजिटिव में एंटर कर रहा है, नेगेटिव से लीव कर रहा। इस केस में क्या होगा? आपका जो पोटेंशियल डिफरेंस है इट इज ग्रेटर देन ईएमएफ, V इज ग्रेटर देन E. So during charging V is greater than E. During discharging V is less than E. There we write V is equal to E minus IR, and here we are writing V is equal to E plus IR. Okay, please write this. कहाँ माइनस IR लगाना है, कहाँ प्लस IR लगाना है? Third is open circuit. So if the terminals of the cell are left open or cell is connected to infinite external resistance, then the circuit is said to be open circuit. What is the resistance offered by air? Air offers resistance, right? What is the resistance offered by air? It is infinite. Resistance offered by air is infinite. ओपन होगा अगर तो एयर है ना, बीच में गैप आ गया, एयर गैप आ गया. एयर गैप मींस रेजिस्टेंस इनफिनिट हो गई, है ना? And no current flows in that case. If the resistance is infinite, then no current flows. If the circuit is broken, if the circuit is open, then there is air gap in the circuit, and air offers infinite resistance. And infinite resistance का काम क्या होता है? It obstructs the flow of current, so no current will flow in the circuit. And V is equal to E minus IR होता है. हाँ जी. Next is short circuit of a cell. तो V is equal to E होता है कब? जब ओपन सर्किट होता है. ठीक है, तो करंट जीरो हो जाएगा ना, IR जीरो हो जाएगा, है ना? I जो करंट फ्लो कर रहा है वो जीरो हो गया, उसको पुट कर दो जीरो. शॉर्ट सर्किट ऑफ अ सेल, this is short circuiting. You can see, look at this picture. If both the terminals of a cell are directly connected with a conducting wire, then the cell is said to be short circuited. So both the terminals are connected through a wire, then cell is short circuited. So in this case, the current through the circuit is maximum while terminal voltage is zero. V क्या होता है? E minus IR. IR V minus V is equal to E minus IR. V is zero. E minus IR is equal to zero. So I is E by R. Maximum current flows in the circuit during short circuiting. Maximum current flows. Because V is equal to E minus IR, and because V is zero, so we can write E minus IR equals to zero. So from here we'll get I is equal to E by R. This is the maximum current which can flow in a circuit. Okay, current is maximum. Because वैसे भी अगर mathematically देखते हो आप, how do we write the formula for current? Current is E upon R plus R, है ना? तो यहाँ पे आपका जो डिनोमिनेटर है वो क्या हो गया? E upon small r रह गया. So we have decreased the value in the denominator, right? It is decreasing, na? It is decreased to, so current increase होगा ना, है ना? What are the differences between EMF of a cell and potential difference? First is EMF is the maximum potential difference between the two electrodes of a cell when no current is drawn from the cell. It is the maximum potential difference. When no current is drawn from the cell, I is zero, है ना? When the circuit is open, V is equal to E. That's the maximum potential difference. And potential difference is the difference of potentials between any two points in a closed circuit. V is equal to E minus IR. It is independent of the resistance of the circuit. Whatever resistance you connect, load resistance you connect, EMF is independent of that resistance. On the other hand, potential difference is proportional to the resistance between the given points. V is equal to I capital R. Yes? Term EMF is used only for the source of EMF, and term potential difference is measured between any two points of the circuit. EMF is greater than potential difference between any two points in the circuit. However, Potential difference is greater than EMF when the cell is being charged. During charging only, V is greater than E. चार्जिंग में क्या था ना, हमने V greater than E. बाकी सब जगह पे V is less than or equal to V. Next we have back EMF of a cell. अब ये back EMF क्या होता है, क्या लगता है back EMF क्या हो सकता है? कुछ ऐसा तो नहीं, कुछ इंटरनली ही कुछ, जैसे आयंस आर मूविंग इन द इलेक्ट्रोलाइट्स, है ना, तो उनका अपना ही इंटरनल करंट कुछ इंड्यूस हो रहा है, ऐसा कुछ हो रहा है, ये क्या हो रहा है, व्हाट डू यू थिंक? एक और ईएमएफ डेवलप हो रहा है, बिकॉज ऑब्वियस है जब चार्जेस आपके डिकम्पोज होते हैं आयंस में, जब करंट आप इलेक्ट्रोलाइट से पास करते हो, सॉरी, व्हेन करंट इज पास थ्रू द इलेक्ट्रोलाइट इट डिकम्पोजेस इनटू आयंस, है ना, ये तो पता है ना, थोड़ा इलेक्ट्रोकेमिस्ट्री सबने किया हुआ है, बेसिक नॉलेज है. So when current is passed through the electrolyte, it decomposes into ions, and these ions travel towards the opposite electrodes, and hence an EMF is in opposite direction of the EMF is developed. And this opposing EMF is called back EMF, and the phenomena is called electrolytic polarization. Okay. To prevent the polarization in Voltaic cell and Leclanche cell, depolarizers like potassium dichromate and manganese dioxide is to be added to the electrolyte. This we have done in chemistry. The terminal difference is 0 in. Terminal difference is 0 in short circuit. In short circuit, V equals to 0. V is equal to 0 and E minus I small r is 0, and we write I as E upon small r, maximum current flows in the circuit. Okay. Next question. In case of a short circuit, the current is maximum grouping of cells. Grouping of cells are grouped together. Okay, then we can find, series, if we have cells in series or cells in parallel, then how do we write the expression for EMF or terminal potential difference? So series combination of cells of different EMFs and internal resistances. So consider a number of cells connected in series as shown in figure. So we have n number of cells connected, and the first cell you can see its EMF is E1, internal resistance is R1, second is EMF is E2, internal resistance is R2, for nth cell is En Rn. Okay, so we know that V is equal to E minus IR. Terminal potential difference across the cells is given by, for individual cells we can write like this, because in series terminal potential difference is different, current is same. In parallel, current is different while potential difference is same. है ना? So we can write terminal potential difference for individual cell. For first cell it is V1, for second cell it is V2, for nth cell it is Vn. So we can write like this: V1 is equal to E1 minus IR1, V2 is E2 minus IR2, Vn is En minus IRn, like this. Okay. So net terminal potential कैसे लिखते हैं? Net terminal potential difference is V is equal to V1 plus V2 to Vn. ऐसे ही करते हो ना? है ना? So net terminal potential difference can be written as this. This is the equivalent terminal potential difference, and we can write this as, in series, current is same, current is constant, I equivalent is I. Okay, and V equivalent is V1 plus V2 plus V3 to Vn. क्योंकि series combination में potential drop different होता है. Across each resistor we have different value of V, but same value of I. Okay. So we can write like this, because V is equal to E minus IR. We can write like this. On recombining, rearranging, comparing, we get equivalent EMF as E1 plus E2 plus E3 to En. We'll simply add the EMFs of individual cell to get the net EMF. Okay. And R equivalent, this is the internal resistance. Internal resistance. Net internal resistance is sum of all the internal resistances of different cells that we have. Okay. And current, we can write for current like this because current is same. तो या तो आप नेट से निकाल लो because V is equal to E minus IR होता है, तो वहां से you can get the value, get the expression for I as this. तो या तो आप नेट वाले से निकाल लो, आप किसी से भी निकाल सकते हो, you'll get the same value of I because I is same. Okay, it is constant. What are the rules for series combination? Equivalent EMF of a series combination of n cells is same as the sum of their individual EMFs. The equivalent internal resistance of a series combination of n cells is same as the sum of their internal resistances. है ना? EMF में भी sum होता है. Internal resistance में भी directly add the internal resistances of individual cells. This is so when the current leaves each cell from the positive electrode. In the combination, if the current leaves any cell from negative electrode, the EMF of the cell will enter the expression for equivalent EMF with a negative sign. Maximum current can be drawn from the series combination of cells if the value of external resistance is very high as compared to internal resistance of the cell. Advantages क्या होते हैं series combination? Where should we use? Where do we use series combination? When large EMF is required, then we use series combination. If we want to increase the EMF of the cell, we use series combination because यहाँ पे क्या है? यहाँ पे E1 plus E2 plus E3. We are adding all the EMFs of the cell. We get the maximum value of the combination, right? So when large EMF is required, there we use. When internal resistance is negligible compared to external resistance. Because internal resistance also we are adding, simply adding na R1 plus R2 plus R3 to Rn. We're doing it like this. Small r को सबको add कर रहे हो ना to get the net resistance. है ना? तो अगर आपकी internal resistance negligible as compared to external resistance, there, then we can use this. Next, we have parallel combination of cells of different EMFs and different internal resistances. So let's consider again n number of cells we have of different EMFs, E1, E2, E3 to En, of different internal resistances, small r1, small r2, small r3 to small rn. Okay, now we have connected all the cells in parallel. So when we connect all the cells in parallel, we know that potential difference, terminal potential difference remains the same in parallel circuit and current changes. Current changes, we have different values of I, but same value of V this time. So consider the parallel combination of different cells as shown in figure. And in parallel, terminal potential difference across each cell and entire combination is same. If the equivalent current is the sum of individual currents, then we can write like this. Equivalent current is sum of all the currents. These are the currents in individual branches that we have. Because we have connected cells in parallel. So we have n number of branches for n cells. For each branch, different current is flowing. So I1 is the current flowing through first branch, I2 through second branch, IN to nth branch. We will simply add all the currents to get the net current. जो main जो current जो आपका जो है इसमें जो circuit में जो flow कर रहा है बाहर वो I है. Further वो divide हो रहा है इस streets में जैसे अलग-अलग branches में वो divide हो जाता है. And V net potential difference is same. But we know that terminal potential difference is E minus IR. है ना? This is the relation between EMF and terminal potential difference. So now we can write I as E minus V by R because I is not same. वहां पे क्या था? V different था, तो हमने V1 plus V2 plus V3 किया और series combination में, तो वो E1 minus IR1 करके हमने ऐसे करके solve कर लिया. But here V is same but I is different, so we'll write in terms of I. Because हम I को add करने वाले हैं, different branches के I's को हम add करने वाले हैं. Okay. So current through first branch is I1, it's E1 minus V upon R1. Through second branch, E2 minus V upon R2. है ना? Through third branch, E3 minus V upon R3. So आपका जो नेट करंट है, इक्विवेलेंट करंट और नेट करंट इज I1 plus I2 to IN. We'll just write for I1, I2, I3 here. Okay. On comparing, rearranging, equating, कर सकते हो ना इतना तो, इधर उधर वेरिएबल्स को, है ना? तो आपका जो E इक्विवेलेंट अपॉन R इक्विवेलेंट है, माइनस V अपॉन 1 by R इक्विवेलेंट, वी हैव रिटन हियर, इज इक्वल टू दिस. इसमें किसी को डाउट है? यू कैन आस्क मी. इधर सविता, आपको, सृष्टि, पीछे बॉयज. Because I1 is E1 minus V by R1, I2 is E2 minus V by R2, I3 is E3 minus V by R3. ऐसे करके लिखा ना हमने. फिर उसके बाद हमने E1 by R1, देखो ये R1 जो है ये दोनों से डिवाइड हो रहा है, E1 से भी हो रहा है और V से भी हो रहा है. तो वी कैन सेपरेट इट. E1 by R1 अलग कर सकते हैं और V by R1 अलग कर सकते हैं, है ना? On comparing we get this. यहाँ पे we can see E1 by R1 minus V by R1. We can write like this for first, है ना? R1 दोनों से डिवाइड हो रहा है ना, R1 E1 से भी हो रहा है, V से भी हो रहा है. And similarly for the second we can write like this, E2 by R2 minus V by R2, like this. And then we will come write them together and these expressions together. नेगेटिव साइन बाहर ले लेंगे एंड कंपेयर कर लो इन दोनों को, है ना? तो ये आपका जो है, this thing is equal to this, right? और जो ये वाला एक्सप्रेशन है 1 upon R equivalent, this is equal to this thing. So now we have got the final expressions for net EMF and net resistance, internal resistance. So we know that this EMF equivalent upon R equivalent is this, and see, ये हमने क्या किया? We had got this expression, right? अब हमने क्या किया? We have moved this R equivalent to the other side, है ना? So equivalent EMF is given by this. इसको समझ नहीं आ रहा आ गया? क्योंकि जब आप इसको R equivalent को वहां लेके जाओगे तो इनिशियली तो यू विल राइट लाइक दिस ना, E1 by R1 plus E2 by R2 plus dash dash dash, and here we have R equivalent in the denominator, है ना? ये यहाँ आ जाए. उसके बाद we have written like this. R equivalent को नीचे लेके जाएंगे अगर तो 1 upon R equivalent हो जाए. वैसे भी अगर यहां से भी देखते हो तो आपका जो ये 1 upon R equivalent है, इसको ऊपर लेके जाते तो ऐसे लेके जाओगे ना, ऐसे ये ऊपर जाके मल्टीप्लाई हो, है ना? Next we have questions based on this. For a cell which is charging in a circuit, V is equal to E, less than E, greater than E, or V is greater than or equal to E. During charging में V is greater than E. ठीक है? Discharging में internal resistance of a cell depends on concentration of electrolyte, distance between the electrodes, area of electrodes, all of the above. When cells are arranged in series, the current capacity decreases, the current capacity increases, the EMF increases, and the EMF decreases. In series, EMF increases. And what is the relation? Net EMF is equal to, simply add all the EMFs of individual cells, E1 plus E2 to EN. So we have two cells, E1 and E2. देखो अब इसमें ना we have a circuit here. ठीक है, I'm going to draw the circuit first for you. ये these two cells are not facing each other. लड़ाई हुई है. And we have a resistor here. Resistance यहाँ पे है. Another resistance here. Like this. Draw करो. खाली क्यों बैठे हो? Draw this circuit, बेटा. 4.5 ohm, 6 ohm, 3 ohm. This is E1, this is E2, and 5 volts is the value. Internal resistance is 0.3 ohm. 9 volt, internal resistance is 1.2 ohm. Okay. This is the circuit that we have. So two cells E1 and E2 in the circuit are shown, we can see, and they have EMFs 5 volt and 9 volt and internal resistances of 0.3 ohm and 1.2 ohm respectively. Calculate the value of current flowing through the resistor of 3 ohm. We have to find the value of current flowing through this resistor. To find current flowing through the resistor 3 ohm. So, देखो अब यहाँ पे क्या है? कैसे करेंगे? First, let's find net EMF. How will you find net EMF? We'll add them. See, they are not facing each other. तो एक पॉजिटिव लोगे एक नेगेटिव लोगे, है ना? कैसे? This is greater, so let's subtract E1 from E2, E2 minus E1. So net EMF is 9 volt minus 5 volt. It is 4 volt. 4 volt is the net EMF, and total resistance is हाँ जी, total resistance कैसे find करेंगे? See, this forms a parallel combination, ना? This forms a parallel combination, and बाकी जितनी भी resistors हैं, they all are in series. How will you find total resistance? 0.3 ohm plus 1.2 ohm plus 4.5 ohm, and this forms a parallel combination. So for this we can write 6 into 3 upon 6 plus 3 ohm. Can we write like this? बाकी सब सीरीज में है तो ऐड कर देंगे. अब जो ये कॉम्बिनेशन से जो नेट रेजिस्टेंस आएगा वो भी तो सीरीज में ही होगा ना अल्टीमेटली, है ना? 18/9 2 ओम आएगा. तो ये जो इसका 2 ओम नेट रेजिस्टेंस आएगा तो ये अल्टीमेटली सीरीज में लगेगा, वो ऐड ही हो जाएगा. ठीक है, वी कैन राइट लाइक दिस. सो नेट रेजिस्टेंस इज 8 ओम. नेट ईएमएफ आ गया, नेट रेजिस्टेंस आ गया. अब व्हाट नेक्स्ट? वी कैन फाइंड करंट थ्रू द सर्किट. Current through the circuit. How do we find current through the circuit? It's I is equal to, बताओ, net EMF is 4 volt and net resistance is 8. So we can write 1 by 2. It's 0.5 ampere. Current through the circuit is 0.5 ampere. Now we have to find current through the 3 ohm resistor. Current through 3 ohm resistance. कैसे फाइंड करोगे बताओ? देखो इसके अक्रॉस आपका ये 6 है ना? एक तो ये कि आप डायरेक्टली फाइंड कर सकते हो. अब जो करंट जा रहा है, वो 0.5 ओम सर्किट में से जा रहा है, 0.5 एम्पियर सर्किट में से जा रहा है। ठीक है, अब 0.5 एम्पियर 2 ओम में से जा रहा है ना, तो इसके क्रॉस पोटेंशियल क्या होगा? नहीं आया। जैसे आपका जो करंट है, अगर हम इस कॉम्बिनेशन को 6 और 3 को 2 ओम ले लेते हैं ना, तो ये 2 ओम में से जो करंट जा रहा है वो आपका 0.5 एम्पियर जा रहा है, तो इसका क्रॉस पोटेंशियल क्या होगा? V इज इक्वल टू आई आर होता है, तो V इज इक्वल टू आई आर होता है, तो 2 इंटू 0.5 इट्स 1 वोल्ट। तो 1 वोल्ट इसका भी पोटेंशियल हो गया और 1 वोल्ट इसका भी पोटेंशियल हो गया। अब इसका क्रॉस करंट कितना होगा? 3 ओम रजिस्टर के क्रॉस करंट निकालना है ना हमने। अगेन 3 ओम रजिस्टर के क्रॉस करंट निकालना है, तो I3 कर देते हैं। ठीक है, I3 करंट, सपोज I3 करंट जा रहा है इसमें से, बताओ। 1 वोल्ट, V इज इक्वल टू आई आर। अब I क्या हो जाएगा? V बाई आर, 1/3 एम, 0.33